DevSecOps track. Or those who have just joined, I'll introduce myself again. So I'm Denise Murtha Dunn, and I'm a volunteer in the OWASP community. I'm currently the Dublin OWASP chapter lead, and I'll be moderating this session today. So during the next 45 minutes on this track, we'll be listening to Jeremy Long, who's going to present to us on the OWASP Dependency Check project. This is a software composition analysis tool to identify known vulnerable third-party libraries within code. So again, similar to before, if you want to submit any questions, you do so during the session in the Q&A tab to the right of the video in the Whova platform. And then I'll be asking Jeremy these questions in the last 10 minutes of the session. So we leave the last 10 minutes for Q&A. Just to let you all know again, or to remind you that the chat function in Zoom is disabled for attendees, but feel free to leave comments and chat using the chat tab in the Whova app. So just to introduce Jeremy, Jeremy is a principal engineer specializing in all aspects of secure SDLC, from training, building standards, creating and implementing tooling such as static code analysis to ensure security is included throughout a development lifecycle. Jeremy is also the founder and project leader of the OWASP Dependency Check project. And for now, I'm going to hand you over to Jeremy, let him introduce yourself and begin the talk. Thank you.
Hello, everyone. Just get started with the screen share here. And hopefully this all works as expected. Okay, can we see the slides correctly?
Yes, I can see them. Thanks, Jeremy.
Okay, cool. Just wanted to make sure that was all working correctly there. Okay, so as we said, this is a talk on OWASP Dependency Check, one of the flagship projects for software composition analysis at OWASP. We kind of did an introduction of me. I'm at CTXT on Twitter, or my email address is jeremylong@gmail.com. Feel free to reach out to me if you have any questions beyond this talk. Okay, so software composition analysis is identifying potential risk from the use of third-party libraries. Traditionally, this started off with legal risk with tools like Palamida way back in like the 2008, maybe around that time frame, 2008, 2009, somewhere in that range. Things slowly started branching out in, I believe, around 2009, 2010, where we very early started seeing people looking for known vulnerabilities. Really more in 2010 is a lot where, or kind of when some of this stuff started taking off. And so this SCA has evolved quite a bit over these last 10 years. We've seen an explosion of vendors in this space, and we're even starting to see an evolution of SCA where we're no longer just looking for vulnerable dependencies, trying to push automated patching for vulnerable dependencies, but we've actually seen some increase in the vendor space around SCA, where we're almost starting to look for 0 days, where we have some of our vendors are out there looking at things like developer reputation, developer commit history, and using some of this to identify when unusual or suspicious activities happen within the open source code repos. That's kind of an interesting way to look at things. Unfortunately, Dependency Check is not doing any of that. I just wanted to raise awareness around some of that really cool stuff that's happening in the SCA space. There's just been so much really cool stuff happening over the years in this space. I'm really glad that it's kind of taken off as how it has. But to kind of just really highlight some of that, I mean, or to go back and talk about the history, the first line of code of Dependency Check was written in about November 2011. So a little over 10 years ago. I can't believe I've been maintaining this thing for that long. The first paper really talking about software composition analysis. It wasn't even called software composition analysis then, was The Unfortunate Realities of Insecure Software by Jeff Williams and Arshan and others in April 2012. I first released Dependency Check in mid 2012. And as I said, we've just seen an explosion of what's happening in the market beyond just some of the traditional SCA stuff that I've been talking about. We're seeing some very cool stuff just now starting to come out from some of these vendors. So one of the things I always like to point out about Dependency Check is, while it initially was implemented to support Java, I also want to point out that it was initially developed as an auditor tool. This was not designed to be something that people would drop in their DevOps pipeline, because there really weren't DevOps pipelines back when I first coded this thing. And so it's been a little interesting trying to help support this over the years, as people are putting tools like Dependency Check right in their pipeline and using it all the time. But the good thing is, how I built it, it was a very extensible framework that I used or designed and built so that it could be extended. And we did see a lot of other contributors add in support for other frameworks, other languages, technologies, etc. I think the most recent addition was Golang. We now support some Golang. The one thing to point out about some of these is that not all of the support for every language is the same. Some of these analyzers are still marked as experimental, and you have to explicitly enable the experimental analyzers when you're using Dependency Check. And that's just to kind of make sure people know that they may have a slightly higher false positive, false negative rate with some of these experimental analyzers, as opposed to the more tried and true Java analyzer that's in there. That's probably the most accurate of them all. One of the other things we do is we do wrap other tools like Ruby's bundler audit, Retire.js. One thing to note about the Retire.js, the usage of that, we're not using any of their NPM code. In fact, I think they are no longer supporting the NPM side of code. I'd have to go back and double check that. But with the Retire.js, they do a lot of the client-side JS. So if you've got jQuery and things like that, and we're using that to find vulnerable client-side libraries. We also wrap NPM audit, PNPM audit, and Yarn audit. If you are just doing a node application and that's the only thing you're analyzing, I would highly recommend just using NPM audit, NPM fix, because if you've seen some of the issues on the dependency check board, you may run into some issues. But one of the reasons why we wrap some of these other tools is for consistency, allowing the ability to have suppression rules, because in some cases you may not want to fix something and it's just causing noise because you know that you're not vulnerable to something that's being reported by NPM audit. And with dependency check, you do have the ability to do suppression rules on specific findings if you've got issues. The other important integration is with the OSS index. Really glad to have that support from Sonatype, where they've provided access to the OSS index. They actually helped write that integration. And with OSS index, we're actually getting additional vulnerabilities beyond what is just included in the raw data sources that we use with the National Vulnerability Database. So along the 10+ year journey, we have created several integrations. I just realized that I didn't put the GitHub action on here yet. That was probably the most recent addition to the dependency check ecosystem, was that we had somebody build out an action. And the cool thing about the action, for those that have used dependency check, is we actually have it set up so that it's building nightly. So it's got a completely up-to-date database. need to go out and pull down new data from the NVD. So it's got a complete nightly refresh of that on that Docker images data. So that's pretty cool. But the one thing to point out, we've got a lot of different integrations. I've kind of put asterisks on some of these here. And the main reason that I've highlighted these are the integrations that work within the build system. These are going to be a lot more accurate than the command line or the Docker image. And that's because they actually pull additional information from the build itself, as opposed to just trying to analyze the files on disk. And so they're a little bit more accurate. And you might get better results scanning with the Maven plugin or the Gradle plugin than scanning the same application with the CLI or Docker image. Where we are today, I know I saw the pull count from the juice shop, and you know, that's a little 40. I think he posted that he had like something like 45 million pulls on the Docker image, which is amazing. But even for me, with just this little dependency check project, in the last, well, it's less than a year, I pulled the stats for August 2021. And for the CLI and the Docker, these are like all-time downloads of the tool, where the Maven and Gradle plugin are just the downloads for the individual month. And we can see that for the CLI, the Maven and Gradle plugins, the downloaded usage of these in less than a year has almost doubled, which is just amazing to me. The amount of people that are actually using this product and hopefully securing their applications a little bit better because of it. And the Docker image, we're up to about 3.5 million downloads all time. So that's pretty amazing. So as I mentioned, we use the National Vulnerability Database as our primary source of vulnerability information. One thing to note is the NVD did introduce rate limiting about a year ago, I believe. So it's vital that anybody using dependency check actually keep a cache of the data directory, especially if you're doing things like ephemeral builds. Alternatively, consider setting up a mirror of the NVD. That's another option. If you're using the Docker image, I forgot to put a link to this. If you're using the Docker image, I can try and pull it up during the Q&A section if people are interested. You can, instead of using the base published Docker image that the dependency check uses, there's actually another Docker image that is used by the GitHub action that you can use directly, and that's always kept up to date. And so that will alleviate some of the rate limiting concerns with the NVD. We also, as I mentioned, we also use the OSS index. What's great about that is there are some vulnerabilities in the OSS index that aren't included in the NVD. And so we get a little bit more accuracy from, well, we get higher accuracy and we get some additional vulnerabilities from the OSS index. So as I said, you know, really thankful that Sonatype provided that integration for the project. And as I mentioned earlier, we also use data from NPM Audit, Bundle Audit, Retire.js. Those are other, you know, data sources. Some of the things in the future that we are considering is using some of the data sources from GitHub, where they have some vulnerability information. And again, that would provide a little bit more accuracy as well because of how their data is structured. We just haven't had time to implement any of those integrations yet. So a little bit about how dependency check works. The first thing to know is, you know, going back to that National Vulnerability Database and the data source. For those that don't know, the NVD contains a list of common vulnerability and exposures known as CVEs. there are other commercially available vulnerability databases that contain more vulnerabilities than are in the NVD, but dependency check being a free tool, we're just using the freely available data source. Luckily, we also have the OSS index to help out a little bit with some of those other vulnerabilities. But there's other vendors like Sneak. There's a few others that actually sell access to their database as well. So each of these CVEs has an identifier, a description of the vulnerability, a risk rating based on the common vulnerability scoring system, and a list of the affected platforms, which are identified by the common platform enumeration of that. So the biggest challenge is library identification, because in order to say that something is vulnerable, you have to know exactly what the product is. Doesn't sound hard, does it? Well, that's because it's a little difficult, because development and security use different identifiers. As I said, in security, we're using the CPE, the common platform enumeration, whereas in development, we tend to use the coordinates. For Java, we use the group artifact version coordinates. Depending on your ecosystem, what's included in the coordinates is a little different, but for Java development, we use the GAV. And as I said, we use the common platform enumeration in security, because we like to attribute the owner or the vendor along with the platform. Where this gets interesting and problematic, and it is historically has been when you have products change owners, like SpringSource was bought by VMware, and VMware then spun off Pivotal. And even within the 3.2.0 range, Pivotal even had two different names in the NVD data for the same Spring framework. Now, there's no comprehensive publicly available database to map between these two. And so, I had to come up with a way of how do we match these. The one thing I do want to point out about the NVD and some of the things that have been happening recently is the problem of multiple CPEs for the same product has been going away. They have been going in and updating a lot of these to standardize on single, so that you've got a single vendor for the single product, et cetera, which has been very helpful. It, however, has caused, for any of the users recently, there have definitely been an uptick in false positives because we were kind of tuned to use these three, especially for the Spring framework. But with the next release, which should be tomorrow, again, a lot of these false positives should be corrected again in the next release here. So how does dependency check actually map these two different identifiers together? We use an evidence-based identification where we extract as much textual information as we can from the dependencies, from the build system. Within a jar file, we'll actually look at the pom.xml if it exists. We'll look at the manifest. We'll look at the file name and extract as much information. We even look at the namespaces, or within the classes themselves, to try and identify the product as well, because a lot of times the product name will be in the package name. And we collect all of that textual information. We kind of categorize it as, this is vendor information, this is product information, and this is version information. And then we use Lucene, which is an amazing high performance search engine. And instead of the standard use case where you're indexing the Library of Congress and searching for 2 words, we've kind of flipped it around, and we're actually having a Lucene index of the product and vendor from the CPEs, and we're throwing a glob of search terms against that to identify it. We've added some additional analyzers and whatnot to kind of make that work under the hood. And this has actually worked out really, really pretty well. We've had a fairly good, it's turned out to be a fairly good way of identifying the dependencies and matching things up. So what are some of the issues with this method? Well, obviously false positives. However, in general, it's not that hard to deal with false positives. The HTML report, which we'll get into a little bit later, has some very good capabilities to help generate suppression rules for these false positives. So it's usually just a little bit of an onboarding task for a new project. The other problem is, of course, false negatives. In some cases, we don't have enough information or the correct textual information from the dependency to correctly match to what is in the common platform enumeration. We do have ways of dealing with these in terms of, we have a hint analyzer, and there's a file format there. It's used a little bit less by users of dependency check, but we do, when we have reports of false negatives, we do go in and update that hint file to help identify some of those libraries that we're missing or not identifying correctly. So I have seen, just to be clear, I have seen both false negatives and false positives occur in dependency check and in the commercial tools in the space. Library identification is not an easy task. Some of the tools I know have used hashes to identify things, and that fails if somebody compiled the dependency from source. Very few, in the grand scheme of things, very few people are using reproducible builds, and so the hash is actually going to be different if you build from source. And so just using that hash-based identification is not always as accurate. And there's other things that have come up to cause issues for both dependency check and the commercial tools to misidentify things. If you ever do run into false positives or false negatives, please open an issue. One of the cool things we've done recently is we are using GitHub, what they refer to as issue ops. So if you correctly report a false positive into the dependency check repo, we will actually run some automated tests against it and put the proposed suppression rule right into the GitHub issue. Makes it a little bit easier for us, for the maintainers, to go in and verify the evidence, and then that it is truly a false positive, and then add that suppression rule right into dependency check. So that's kind of something that was pretty cool that we set up, and I intend to expand the issue ops and support for false positives quite a bit more. But again, if you do run into false positives, false negatives, please report them. As I said, dealing with false positives is fairly easy with dependency check because we can just generate these suppression rules. The HTML report has a button on there to click and just generate these suppression rules so that we can quickly and easily remove these from the reports in your running instance. As I said, you can always report this back to dependency check, and we can try and get some of these false positives taken care of at the source. This one is a suppression rule for Spring Security, obviously, if you can read there, because it's misidentified as mod security, the Spring framework, and so we have suppression rules against those. One thing to point out with the false positives that we generally get from dependency check, in a lot of cases, they're really obvious. If you just look at the HTML report, they're going to be complete mismatches. There might be a different technology stack. And if you just look at the CPE, the identified CPE, and basically what the dependency is, most security aware developers should be able to go that's a misidentification, and then quickly and easily suppress based on the CPE or the package URL. the suppression rules, while the CPE one still does work, we are more commonly using the package URL in the suppression rules. It's just a standard, a different standard on how to instead of using the GAV, the group artifact version, we're using the package URL. And that's just a more standard way to be able to identify packages across different dependencies across different types of technology stacks, NuGet, Maven, etc. So that is a little bit about the false positives. So if you actually go in and start using dependency check, how would you go about doing this? As I said, generally you would go in, it's a fairly simple task. You'd go in, hopefully you're using one of the build plugins as opposed to like the Docker or the CLI. So you'd go in, you'd configure the build plugin. If you are in an environment where you have to use a proxy, you will have to configure dependency check to use the proxy, because we do pull down information from the internet, such as we cache a local copy of the NVD. Depending on the integration, and how things are configured, the tool may also reach out to GitHub to pull down the latest retired JS data. If you're scanning NPM, we use the NPM audit APIs, so it will be reaching out to NPM. So it's not just something that runs very easily in an offline mode, although you can completely configure dependency check to run in an offline mode. But you'll have to look at some of the documentation to get that to fully work, and you'll have to do some things in your environment to cache some of the data and to turn some of the analyzers off, just so that they can correctly work in the offline mode. If your build environment cannot reach out to the internet, one of the things that people have done is set up a mirror of the National Vulnerability Database, and that way they have that locally in their environment, and they can just update based off of that mirror, and they don't actually have to reach out to the internet. That's another thing that people do quite commonly. So once you get the plugin set up and configured, some of that initial, depending on your environment, some of that initial setup is easier or not, all depending on how secure your build environment is and how isolated it is in your organization. Once you've got it set up, the steps are you just run your initial scan, look at the results, determine if there's any false positives that you would need to create a suppression file for, and then plan the upgrade for any of the identified vulnerable components. It's fairly straightforward, and we will try and do a demo here. So again, I actually have not done this yet. We're just going to do this live here. I have no idea if there's anything in JSoup or not, but we'll just start by cloning JSoup. And it's just a library that's used for parsing HTML. So one of the first things that we'll do here, I need to move some stuff around here. 1 second. So in JSoup, one of the first things we have to do is go into the pom.xml. And right here in the build plugin section of the POM, I did cheat in that I have this copied, but we just add the dependency check Maven plugin to the POM. And then we can save that change. Jump back over to the command line. Normally you could run this just based off of the verify goal, but because I don't know if JSoup has any weird issues with how it compiles and runs its tests. I may not have everything set up in my environment for JSoup. I have, again, like I said, I have not actually tested this. So we'll hope this demo goes well. So I'm just gonna run the aggregate goal. There's also a check goal. Aggregate is used when you have a project with child projects, or like a multi-Gradle, a multi-project Gradle build. There's an aggregate goal for the Gradle plugin as well. This did run fairly quickly here because I did update the cache of the NVD. That can take, you know, a couple of minutes, 2 to 3 minutes or so, depending on things, on the configuration, how fast your internet connection is, if you hit rate limiting issues with the NVD, etc. So looks like a fairly small report. So I will pull that up here. And unfortunately, you know, for me, well, actually great for JSoup, they only have one dependency, it looks like, and that there's 0 vulnerabilities found in it. And you can kind of click this little button to, we start off just showing only the vulnerable libraries, but you can click this little button to actually show all the vulnerabilities. And this just shows some of the information about the one dependency they have. Looks like the JSR 305 annotations for find bugs is the only thing that they have in their code base as a dependency. One of the things to point out, and I'll just show this really quick, is, as I said, there's a lot of evidence that's collected, and we put that into like the vendor, the product, and the version evidence. And that's how we then use to search for vulnerable versions for CPEs within the NVD, so that we can identify the vulnerabilities. Okay, so we didn't really see anything in JSoup. I was hoping to actually, you know, randomly pick a project earlier and see what something looks, and just see what it looks like. But good deal for JSoup, they don't have anything. So to show you what a report with actual vulnerabilities looks like, I do have I have a little side project that I have, ODC false positives, and that's one of the things that I have historically, before I built the issue ops. I've just had this little side project with the Maven plugin set up, and I would just put, when somebody reported false positive, I would just put it in this project so I could create the suppression rule. This one does have a vulnerable version of the Common Collections 3.0 jar. Here we can see that, you know, the CP is Apache Commons collection, so that is likely a 100% accurate match. I mentioned the package URL. That is what we are using now for as many of the ecosystems as we possibly can, trying to correctly determine the package URL, because it's a fairly good standard for to have a single identifier that can go cross technology, because you could have, this is Maven, you could have NuGet, other types of packages, all identified by this single schema, going out to the versions, and there's other information in there. And as I said before, if this was a false positive, it's generally going to be fairly easy to identify that it's a false positive. But it's one of those where I don't have a good example to show you why we think some of these are false positive. If this was a false positive, I said it was very easy to generate the suppression files. You can just click this button and it generates the suppression node. If this is the first time that you're generating a suppression file, you can actually click this complete the XML file, and it'll actually put the headers and everything in there to use the latest schemas and everything else. And then you can just simply go in here and copy that, and just hitting Control-C with that in there closes that window, and you can go paste that into a file and then configure the plugin to use the suppression file that you created. One thing I will point out, I've seen a lot of people trying to suppress or even report that, hey, dependency check identified that the Commons collection Maven library, Java library has a false positive on this specific CVE. And 99% of the time, it's not that it's a false positive on this CVE, it's that it's a false positive on the CPE. And so people try and report and suppress on individual CVEs, and that's kind of the wrong way to go about it, because it's generally that we have the common platform enumeration just due to the evidence-based matching is incorrect. Just suppressing on the specific CVEs is generally going to end up being problematic, and you're just going to see the next time a new CVE comes out for that library, you're going to see it. You're going to see a false positive show up again. There are cases where I know we have this capability in here because there are cases when people will want to suppress a specific CVE because they know that they're not vulnerable, or within the suppression schema, there's actually an until attribute. And so you can suppress something until a future date. Maybe that you've worked out with the development team that they're going to patch this, but it's a lower risk issue and they need 6 months to go about that. And maybe they put it on their backlog, etc. And I've seen some users actually then just go put a suppression in for that CVE for using the until attribute so that it stops being reported because they know it's on the backlog, they know it's a lower risk issue, and the development team, just due to needing to deliver features, whatnot, have not spent the time to upgrade this library. So that's just kind of a high level of overview of dependency check. There is some great information out here on how to read the report and suppressing false positives. And of course, you can go out to the GitHub issues to get more information about this. Okay, so we'll go back to the slide deck here. So what are some of the use cases for dependency check? Like one, if you're not aware of this, of the software composition analysis problem yet, and your company, for better or worse, hasn't done anything in here with software composition analysis to identify known vulnerable libraries, you can at least use dependency check to prove that the problem exists. Another one, I've seen people use dependency check as a baseline test when conducting POCs with some of the commercial products. You'll see, as I mentioned, you might see some false positives, you might see some false negatives, depending on what technology stack you're using. I've seen bake-offs where dependency check, was a fairly good head-to-head competitor. One of the main differences why vendors or some of the companies have gone with the vendor solutions as opposed to dependency check, well, they wanted to ensure that they had support that is not just relying on a handful of developers in the open source community. Not saying that that's a bad thing, but I mean, it all depends on the company and how much support they want to have for some of these things. There are many companies that I know of that use dependency check within their CI/CD pipelines. They are just continually scanning all the time. That's part of why the download counts have been increasing. And I believe that's partially due to some of the usage of ephemeral builds that we have going on in the environment right now. Another one, like I said, it's just used as the primary tool for some companies. And the interesting thing is that some companies actually use multiple SCA tools. That's because, in my opinion, software composition analysis is one of the most critical security testing that can be done, because when there are, like, a lot of the stuff identified by SCA tools is really, you question the exploitability of it, or sometimes it's a lower risk. But there are some vulnerabilities. Hey, Log4j, for instance, where you need to identify this and you need to patch it as soon as possible. Software composition analysis identifies these known vulnerable risks to your application. Because it's a known vulnerable risk, there may be exploits available in the wild that script kiddies can just scan the internet, trying to exploit these things. Some of the big breaches over the past several years had a starting point with software composition analysis, where somebody had a vulnerable version of struts or a vulnerable version of whatever library, and it had a remote code execution in it, and that was the starting point to a breach within that organization. But definitely not all SCA findings are equal, but it is a critical piece, because when those severe vulnerabilities come up, you need to know about them, because they're well known, and because they're well known, they become easier for attackers to exploit. So how can you help? If anybody really wants to help out, one, we have about 350 open issues, questions, enhancements, bugs, false positives, etc. And unfortunately, due to the usage, this number has been increasing, and we could really use some additional support. We have several contributors. Mark Prine, I believe, is the guy's name. Amazing contributor. He goes in and answers so many people's questions about dependency check. Hans is one of the other main contributors to the project right now. He's been doing a ton of development work, supporting, helping clean up some of these false positives, answering questions, etc. But we really could use more help as the tool continues to evolve and expand. One of the things that we've been talking about for a few years now is actually building out a full enterprise deployment guide, because we've seen people do it correctly and incorrectly over the years, talking to people. So if it's something where you have successfully deployed dependency check within your enterprise, it would really be great if somebody could contribute back to the project the best practices that they've used as they're deploying it within their enterprise. Lastly, we could really use, while I've been the core maintainer of the Gradle plugin, we could really use a Gradle expert, somebody who can really understands plugins, because we have occasionally run into issues with Gradle where we have dependency collision, and the plugin stuff doesn't work on some projects. My understanding is that we can rewrite the plugin to use the worker API instead of how it's written as a plugin today, and that should isolate the dependencies so that we don't run into that conflict anymore. We have an open issue on that. Again, I just have not personally had the time to work on that. And so we would really appreciate if anybody does have the time or inclination to help out with the project. There's a lot of work to be done. So I think right at about 45 minutes or so, I think we're ready for questions.
Yeah, that was great. Thank you so much, Jeremy. That was really interesting. And we do have a few questions in here from the audience, so I will get started with those. They have asked, does the tool identify vulnerabilities on second level dependencies?
Okay, second level dependencies, a lot of time those are referred to as transitive dependencies. And yes, well, to a point, let me re-answer that. To a point, it will. If you are using a build plugin like the Maven or Gradle build plugin, absolutely. That's one of the benefits of using the build plugin. If you're not using the build plugin and you're just using the command line tool, the only time the transitive dependencies will be identified is if they're in the scan path, that you've downloaded and put all of the dependencies in a single path. That's one of the mistakes that I've seen people make with like Maven or Gradle projects is, here, let me see if I can actually show the example. Again, I've not actually built this project, but let's see if it works. I just ran Maven package on the JSoup. You saw that it had one dependency. So if I just did the build, you know, it's going down. Some of these things might be build plugins and other types of things, not necessarily dependencies. Again, I haven't gone in and looked at this project at all. So hopefully this will be able to demonstrate the problem that I've seen people do with just running dependency check on a Maven build and where they're running into problems. So we did a build. It was successful. And if we look at the target directory, a lot of people may just scan the target directory. Well, all we have is the JSoup lib here. We don't actually have, I mean, if you actually dug into a lot of these directories, we don't have that annotations library or any of the others. But if we then go in here and run hopefully I have that right. Hey, I got it right. Okay, so one of the things about the copy dependencies, then it actually puts the, wow, I'm gonna have to go back and look at this project. Why are we having, oh, some of these are look like test dependencies. Okay, so it copied all of them. That's within dependency check, we do ignore test dependencies. So that may be something I'll have to look at a little bit, but you can see the JSR right here is identified. That was the dependency that was identified by dependency check. Again, my guess is that some of these are either in scope, yeah, like in part of the testing, because this is a HTML parser. I could easily see some of these things being part of the test case and may not be a core dependency. Again, I'll have to go back after this talk and look at that. But my guess is a lot of these are test dependent. Most, if not all of these, are test dependencies. So unless you were doing a Maven build, unless it was building a war or a Spring Boot as the target, dependency check may not actually find the dependencies if you were using the command line or the Docker after doing a build, unless you did the copy dependencies task. Any other questions?
Yeah, we still have another couple here. The next one is, does the tool work on vendored libraries?
On vendor what?
Vendored libraries. So I'm presuming that means on libraries that are owned specifically by
specifically owned by a vendor.
Yeah.
Yeah. So commercial libraries. Yes, it would. If you know, for instance, if you had like an internal Nexus or Artifactory or something, and your build, and you had loaded some commercial libraries and you brought them into your build, yes, they will be identified. Will there be known vulnerabilities with them? Maybe, maybe not. It all depends on whether or not the NVD has, if any of those CVEs have been published against that library, because sometimes the commercial libraries, some of the data may not end up in the public data sources, or even some of the private data sources, just because it's a private library or a commercial library that not everybody has access to.
Okay, that's great. And the next question is, are you working full-time on dependency check?
Not a bit of it. I have a full-time day job. What shocks a lot of people about dependency check is at my day job, we don't even use it.
Okay, that is interesting.
It was used for about maybe the first year or two the dependency check was around, but for many reasons we went with a commercial product, and dependency check was used for a while within a group doing audits. Like I said, it was originally built as an auditor tool, where we were auditing source code, and software composition analysis was one of the things that we were looking at, even though it wasn't called SCA back then. But yeah, no, I've continued to maintain this. Historically, a lot of my development work has been, if you look at my commit history, it's been between 5 a.m. and 7 a.m. before the rest of my family is awake.
That's commitment. I guess the next question is, have you worked with universities to improve the results, such as the false positives and false negatives?
No, really have not. I know that I've had some conversations throughout the years with various people doing interesting work in their PhD programs around identifying if the vulnerable code was used, because that's one of the big issues with SCA is, I may have a vulnerable library, but is the vulnerable code actually used or exploitable in any way, shape, or form? And there's been some really interesting things going on around that type of research. I think MergeBase may be doing something interesting in that space about if things are vulnerable or not. So that may be a company to go look at. Okay,
that's really interesting. Thank you for that. Another question that has just come in is, most modern projects use several programming languages. Are you trying to support more programming languages going forward?
Yes, we are. I mean, that's one of the reasons use cases for dependency check is, like, even if you're using NPM, you might be just doing your front end with Node, but your back end is written in another technology stack. And that's one of the reasons why some people are using dependency check, is because it consolidates your NPM, which you can do with NPM audit and NPM fix, but you can really get a more consolidated view of your entire application by using dependency check. I will say a lot of the integrations that we have come from pull requests from people requesting support for other languages. More than happy to help work on those and improve them. But it all starts with somebody at least raising an issue, providing some sample, projects for us to look at, and we can take it from there.
Excellent, thank you. And are you trying to improve the CLI detection, which does not require to add dependency check into the build system?
Well, I'm not necessarily sure that I'm working to improve the CLI a whole lot. I mean, other than just improving the entire tool, because all of the integrations do run off of a base dependency check core library. And we do continue to work on that. One of the interesting things there is I am seeing some hints that the NVD may be incorporating additional data that will improve our accuracy quite a bit and get rid of some of that false negative, false positive. One of the things that have been working on is we kind of have a script that we've slowly been building out. It's posted in a couple of the issues where instead of necessarily just running the CLI, you could just run this script and it would pick between, it would identify if it's a Maven build, if it's a Gradle build, or something else, but it would pick the Maven and Gradle are the main ones. And if it was a Maven or Gradle build, it will actually run dependency check using the plugin. And if it's not, it will revert to just using the CLI or the Docker image, I forget. But I mean, you can swap the Docker image or CLI out in that script fairly easily. That's something that I probably need to promote a little bit better, because that script would be something that would be very useful to drop into some of the build pipelines.
Okay, great, that's fair enough. And another question that has just come in is, can we create our own data source with internal library information?
That one that is an outstanding issue or enhancement request on dependency check. At the moment, it wouldn't be that easy. You don't, yeah, it just wouldn't be that easy to do. I could envision a way, kind of a hacky way of making that happen. But, you know, open up, you know, comment on the issue on GitHub if you want to know more. And I can kind of come up, I might be able to come up with a way of doing that now, but no, it is not something the team has really started building out yet. It would be easy enough for a developer to extend the product to add additional data sources though. So.
Okay, and just to confirm, has that already been put in as an enhancement request? Yes. Or are you asked? Okay, so it has.
No, yeah, sorry, I should have been clear. There is, almost positive it is still an open enhancement request in the 350 or so open issues.
Okay.
So, as I said, there's 350, so.
Great. And then another question that came in. So how do you go about gaining the support from your partners, such as OSS Index for integration?
I haven't yet. I haven't reached out to any of the people in any of these other groups. I've got a lot of interest in several of the things that have been going on there with the OSSF. And I just have not, between my day job, the time I spend on dependency check, and some other personal projects, I have not reached out to them and worked on anything with them, although it's on my list of things to do. We'll see.
Okay, great. And last question, just before we finish up. When in the SDLC do you recommend this tool to be used?
Early and often. Honestly, it's one of those where the sooner that you know about vulnerabilities, the sooner you can, you know, remediate them. Especially, again, I tend to more focus personally, it's my own personal opinion, not any of my employers, etc. I tend to really, you know, focus on some of those deserialization, remote code execution type vulnerabilities, just because those are truly, truly dangerous out of the gate. Try and get those cleaned up as quickly as possible. And that's why I say, you know, run it. I mean, like, if you have the capability, there is a GitHub action. If you're using GitHub, you can use this as GitHub action. Again, you could also, depending on your environment, if you're using GitHub Enterprise or not, there's also Dependabot, which does, if you're using GitHub, can do some similar things. The one thing about Dependabot, depending on your technology stack, they may not cover transitive dependencies. But there's a GitHub action for dependency check. So run it early and often. Even on your pull requests, if possible, because that way, if somebody does introduce a new library, to your application or a new version, you can get notified immediately if there's an issue, even before merging that in. And then you can work to clean that up. And rather than propagate having risk in your code base, you can clean it up before you push that release.
Okay, yeah, so early and often, everyone. That's it, that's a wrap. So we just want to say thank you for taking the time to speak to us today, Jeremy. There's a lot of comments in the Q&A section as well saying thank you. One person saying you're a legend, so take that as you will.
Yeah.
And hope to see you again soon. For everybody else,